So today we're gonna cover this question. So we have a hockey puck with mass 0.45 kg. It's coming from the east direction with a speed of 4.2 meter per second. Has a head-on collision with another puck, which is initially at rest with mass of 0.9 kg. Assuming a perfectly elastic collision, what will be the speed and the direction of each puck after the collision? So first, let's write out the data we have. We have m1 is equal to 0.45. Initial velocity of first puck will be 4.2 meter per second. Mass of second puck will be 0.9 kg, and initial velocity of second puck will be 0 because it is at rest. So this is our general formula for momentum. It's like momentum P is equal to mass times velocity. So we will use this formula, and in this case, momentum of puck 1 plus momentum of puck 2 before the collision is equal to momentum of puck 1 plus momentum of puck 2 after the collision. Why? Because total momentum in this case is conserved. So there is no loss of energy. So we can say that P1 plus P2 is equal to P1 plus P2. So this is the before collision and this is the after collision. So P is equal to mv. So let's substitute the value of mv. So m1 v1i is equal to m1 v1i plus m2 v2i is equal to m1 v1 f plus m2 v2 f. Now this is the initial velocity of both the pucks and this is the final velocity of both the pucks. So f means final velocity and I means initial velocity. So as we know that our initial velocity of puck 2 will be 0, so this term will become 0. So this term will be as it is and this whole term will be as it is. Now let's apply the value of all the variables. So mass of first puck will be 0.45 and the velocity is 4.2. Mass of first puck will be same and mass of second puck will be 0.9. Now we have to find these two variables. We don't know the final velocity of puck 1 and final velocity of puck 2. So by multiplying these two values we get 1.89. So here let's say this is our equation number 1. And this is the general this is the formula for kinetic energy. So this is a general formula. K is equal to half mv square. So similarly as we have done here, our total kinetic energy is conserved. So we can say the kinetic energy of puck 1 plus kinetic energy of puck 2 is equal to kinetic energy of puck 1 plus kinetic energy of puck 2. So this is the before collision and this is the after collision. So kinetic energy of both the puck before the collision is equal to kinetic energy of both the pucks after the collision. Let's apply the values. So half mv square for the first puck, half mv square for the second puck. So m1 v1i, m2 v2i, and of course don't forget the square. And it's similarly half mv square for the second puck and half mv square for the other puck. So m1 v1f, m2 v2f. F means final velocity. So as we know, initial velocity of our second puck is 0. So this whole term will become 0. So we have this term as it is here and this whole term as it is here. So here we can see our next equation. So we have half, both the side of this is equal to. So we can take out this half, and substituting the value of our variables. So the value of m1 is this, value of m1i is v1i is this, m1 and m2 both the mass of these are both the mass of both pucks, and we still don't know the value of v1f and v2f. So we simply keep it as it is. So by multiplying or solving this side, we will get 7.938. So let's say this is our equation number 2. So now we have our both the equations, equation 1 and equation 2. So we will take this equation 1 and we will put this v1f subject to the equation this side. So let's say this is our equation 1. It's a same equation. So let's make v1f subject to the equation and subtracting both side by 0.91 to f. 0.91 to f. So this will come this side and becomes positive, negative. This will come this side and becomes negative. So here it is. And on the right hand side, 0.45 v1f will left. Now dividing both side by 0.45. So this term will go here. So this is our final equation by making v1f as a subject to the equation. So let's name it as equation 3. So now we'll use the value of v1f and we will substitute in equation 2. So substituting the equation 3 in 2. So this is our equation 3. So let's divide these two value, it will give us 4.2. And if we divide these two value, it will give us 2. So we will use this in place of this. So this is our second equation 2, and we will substitute the value of v1f, which is this. So now this is how our equation will look like. Now we know this formula: a minus b whole square is equal to a square minus 2ab plus b square. So we will apply this formula. This is our a and this is our b. So a square minus 2ab plus b square. So this is a square, and other all the terms will be as it is. Squaring this will give this, and multiplying all this term will give 16.8 v2f, and this is simply square. Now multiplying this inside this bracket, so this goes to here, this goes to here, and this goes to here. This should be like this, 4 square. So this is not correct. This will be look like this, and this both term will be came as it is. Now multiplying of these two will give this value, and multiplying of these two will give this value, and this will give this value. Again this both term will be came as it is. Now this will go on this side, then it will become negative, and it will cut this and become 0. Or you can just subtract both side by 7.938. Subtracting both side by 7.938 will give you 0 on this side, and in this side we have left this whole term. So in this whole term, by adding these we will get this, and this is as it is. Now taking common v2f from both the sides. So if we take v2f from here, then there will be 1 here. So 7.560 times 1 will be same. And if we take v2f here, then still 1 v2f is left because of square. So now we can say this value is equal to 0. So this is what it looks like. Now this, if this goes to this side, like opposite to the is equal to, then it will become positive. Or you can add both side by 7.56 and dividing both side by 2.7, then you will get this equation, and dividing this will give you 2.8 meter per second. Now the value of v2f, which is 2.8 meter per second, we will substitute in our equation number 3. Yes, we will substitute in our equation number 3. So this is our equation number 3, and we will substitute the value of v2f in this. So 2 into 2.8, subtracting and solving these further will give you minus 1.4 or negative 1.4. So this is the final velocity of our second puck, and this is the final velocity of our first puck. And we get this as a negative because this is in the opposite direction. This is in the east direction because first puck is moving from west to east and moving towards the another puck which is on rest. So when they collide, the first puck will go in this direction, and second like the puck which initially have v is equal to 4.2 meter per second will rebound and go in the opposite direction. So you can say that this is on east direction and this will rebound or in west direction.